So here's the gripper wrist attachment. Inside of here is a servo motor, and that servo is about as small as we can get to have the right amount of torque to actually open the hand up. We've got a string which is tied to the thumb that you can see running through a channel that goes into the back where all the servos are. We have that running externally right now, but I've got a thumb 3D printing that has a channel through the inside of the thumb. So this will run through the inside and just run straight out the back. And we'll probably be running a PTFE tube of some sort through from the wrist attachment to the thumb itself for the string to run down to kind of try to waterproof a little bit and give a smooth channel. We've got everything attached through two M3 screws, M3 by 60 that screw through, we'll screw through to the other side to get this a nice firm attachment on the end. A little bit of space in these gaps that we'll probably put some neoprene or something, again, for further waterproofing to make a kind of waterproof, watertight seal. We've got the back end is coming the servo. The servo motor is the only thing that's right now housed inside of here so that we can minimize the amount of bulk that we're adding to the actual hand terminal device that'll hang at the end. So these kind of casings, this internal casing right here on the back, that's going to be standard for the servo motor. And then we can create whatever kind of back and front attachments we need to attach to whatever terminal device you might want. So the idea is this is going to be modular. Everything is attached with M3 screws. So we got some M3 screws here attaching this little sleeve on, and we'll have another M3 screw right up here at the top. So we'll have 3 attachment points to make it nice and secure. That's not budging. Then our wire comes out of the back and brings us to this part. This part is the control box. So the control box is about as small as we can get it because of the batteries that you need to run something like this. I've got easy kind of batteries to find. I've got AA rechargeables. So we could go with 18650 lithium ion batteries to recharge. Those should work as well. I just think AA's that are rechargeable are a little bit easier to find. So I'm working with that for the moment. Inside of here is all the wiring, and you can see the kind of Arduino LED that's down here at the bottom, and then the battery pack, a pack of 4 AA rechargeable batteries. And then the nice thing, any wires that you want to attach things to, you can run through this little slot. And then on this side, you actually have port access to the USB port for the Arduino and a DC power jack. And the DC power jack, you can just plug this in to recharge it. So you don't have to open this up and take out anything for charging or maintenance purposes. You can just plug it right into the computer, or you can plug it right into a power outlet with the DC jack. Now this one is set up to work with a simple tactile button switch. Where I'd like some feedback is other kinds of switch control mechanisms. Not entirely sure how somebody would actuate this little button to actually use this kind of device. So that would be helpful. We could mount it somewhere on the front. We can mount it up where the servo is. Then we just need to run these wires back up. That's not a problem. And then they can push on it by pushing the object itself against something and make the device open and then close. We can put this kind of little switch anywhere, and we can change the kind of switch we have. So if any prosthetists or any people have ideas about the kind of switch to use here, let me know so I can integrate it in. It should be relatively easy because we're going to use the same kind of control mechanism. It's an on or off kind of device. So we just need to plug into the 2 ports, and we can switch these out pretty easily because I'm using headers instead of soldering wires directly. So the way it works, you just push the button, and as long as you're holding the button down, the finger will open. Since we're on an Arduino, we could change that. We could make it so that you push the button and the thumb opens and stays open for a certain amount of time. We can make it so that there's a delay on the push, so you have to hold it down for a certain amount of time, and then it'll open, and then it'll stay open, and then close after a certain amount of time. So we can kind of calibrate that and get it working very well with whatever a user might want. And we can, again, do that all through the USB port that's in the side. That's pretty much everything. So this is the first draft of the Gripper terminal device that I'm going to be sending out for people to play with. There are instructions kind of written up on everything that you need for it. I'm working on tweaking those, hopefully to release by the end of the week. All the files that you need also to release by the end of the week, and all the coding, and then the cost and bill of materials that you need. It's about $42 total for one thumb device, but that's spread out through a bunch of different Amazon links that you can purchase it from. If you do the Amazon links that I provide, the total cost is about $103, but it includes excessive amounts of material, so it has more than you need to build one device. So you can stock up and build multiple devices. Yeah, so we'll go through and we'll do a internal look at all the internal components as well. If you have feedback or ideas, let me know. Other than that, here's the Gripper terminal device, actuated by switch.